Hello everyone, my name is Carlos Marfil.
And I'm Oliver Ökvist. And today we're going to take you through our project that Carlos and I have been working on for the last couple of weeks. Why this project? The reason why Carlos and I chose this project is because of Scribble.io. Scribble.io is a free multiplayer drawing and guessing game. So it's basically a online Pictionary. And we really like the online aspect of the game. So we wanted to replicate that and create our own unique tic-tac-toe game. And we're very aware that there are similar ones out there already, but we ultimately wanted to replicate a similar environment to that of our first dev jobs, learning a new technology and pushing our knowledge to adapt and find creative solutions to the challenges we faced. We also took this opportunity to expand our tech stack, incorporating some tools and libraries that align with our personal passion and interests. When Carlos and I started working together, we quickly realized that time management was key to improve our efficiency and for them to pull off this project. And we did this by creating a feedback loop where we would review what the previous person had been working on and take it from there. But of course, we couldn't do this with our agile tools. And to start off, we used Figma to brainstorm and draw our thought processes and logic, Slack to update each other, create records of minutes and actions after each daily catch up. And last but not least, we used Asana to keep a timeline for the project. This tool was helpful to assess progress against a 2-week timeline.
I'm going to take you on a quick demo of the Tic-Tac-Toe app. As you can see, we have two windows open, each one of them representing a different client. First thing, you input your username, in that case Carlos, and in here is going to be Oliver. Then you're in the lobby, so you need to enter a room code to create a room, or click on a room button in order to join. I'm going to create 13, and now if you refresh the rooms, it should appear here. Now that we're both connected to the same room, we're going to use the chat function to say hello to each other. Hello, Oliver. Hey, Carlos. And now we're going to play. So as you can see, it says make a move. It says make a move there. The reason why we've done that is to balance a little bit more the game, because it's a tic-tac-toe, but it's a little bit bigger. We just wanted to make it like more fun. As you can see, you always play with the reds, and the yellow represents the rival's moves. And once you win or you lose, it shows in there.
Before we decided on the tools we would use for this project, we did a great amount of research. From old abandoned GitHub repos who aim to do similar things, documentations for relevant tools, and YouTube videos to articles and Stack Overflow discussions. And then we decided to use a lot of technologies that we are very familiar with, as you can see on screen, for both front end and for back end. We also did a lot of research about WebSockets. And we were briefly interested in a tool called Stream Chat. But in the end, we decided to incorporate Socket.io into our project. And Socket.io is a library that enables us to be able to communicate in real time and event-based between a user and the server. And I would like to hand over my time to Carlos, and he will explain a bit more.
From our very first conversations that Oliver and I had, we knew that one of our priorities was to implement a multiplayer feature for this app. We were very inspired by browser-based games, and we really wanted to learn more about the technology that they use to create this user interaction. We researched for quite a bit, and then we ended up coming across WebSockets. WebSockets are just communication protocols used in client-server communications. In the end, we chose Socket.io, which is a library that uses WebSockets, but it allows you to do much more with them. As you can see in this diagram, you have a server that talks and communicates with different clients, but within the server you can also create rooms that allow you to separate different clients into their private space where they can interact. As you can see, the structure of your project, we have a server in the repo, which is a basic Socket.io server, and then we have a React app with lots of components that communicate with Socket.io in an event-based way. Now I'm going to show you a very quick snippet of code so you can see Socket.io and this event-based communication in action. First of all, over here you can see your basic Express API, you can see your server, and you can see that we're using CORS to manage the communication between front-end and back-end. And over here we have the first snippet of Socket.io code that you're going to find today. IO sets a server, and in here we're creating the connection. So every single client that connects to this server is going to have access to lots of events that are nested within the connection. You also see some of a few methods that we're going to be using, in this case on and emit. Emit is triggering an event and is sending some data to that event, and on is listening for an event to trigger it and is receiving some of that data. As you can see, events take two arguments. The first one is just a string, is the name of the event, and the second one is the data that it's either receiving or passing on. Now we're going to take you through some of our features and components and some of the Socket.io events that we use to implement them. First of all, the lobby. As you saw in the demo, you can input a room code, then you can save and join or join a previously created room. Now I'm going to take you through the join room component, which is a component responsible for the lobby. We're going to have a look at the rooms state, which in this case is an empty array that will get updated as someone creates rooms, and then it's going to get mapped into rendering the buttons that you can click to join the rooms. These presented two challenges. The first one is that every single client connected to the server had to share the same rooms state, so they had to be synchronized. And the second one is that when you navigate from the lobby into one room, the state would reset. In order to overcome this challenge, we use local storage. We're going to have a look at the server now. As you can see, we have to declare a row rooms array, which in this case is going to include every single room created through all the clients connected to the server. And as you can see here, we have an event receiving a room code. So when you input the room code and create a room, that's going to trigger an event that the server is listening to and is getting that room code here. Then row rooms will get pushed the room code, and then the client would join the room. Local storage doesn't allow us to store any arrays. So in this case, we're going to declare another variable, row rooms string, and we're going to stringify row rooms. Now we're going to use another method for Socket.io, in this case broadcast, that allows us to send, to emit data to any other client but our own. Row room string incoming, and then we're going to pass on the stringified row rooms to the component. Back to this component, as you can see, Socket.io is listening to this specific event and receiving the data. As you can see down here, we're setting an item within our local storage called lobby, which is row room string. And then up here, we've declared a variable called lobby that's returning that string into its original array state. And then finally, we're setting the room state to the lobby up there.
So here we have the board component, our main component. In our main component, we have a board state, and that is an object of arrays. And as you can see, there are 7 different properties called column 1 to 7, and they all have their own value, which is an array with 6 empty strings, just like in real life Connect 4 board. And then we have different state that handles turns and win and loss. And then further down, we have our cell component, which handles each cell, and it has an ID and the text. So by clicking a cell, the handle cell click function will be running. And what happens is that you're grabbing the ID, which is a string, and we're splitting it into column and position. And then we're running the if statement, checking if we can play. And then we're updating, checking if the spot you've clicked on is empty or not. And if it's empty, we'll update the board on its column and position with the red token, as you can see on line 61. And then we're setting the board, and then we're sending all the information to the server with socket.emit. And then we're setting the state to false, and then we're running a winning function on board to check if you won or not. And then on the server side, we're translating the move to the rival's move. So as you can see on line 23, the opponent will have a yellow token. So you will always be playing as red and the opponent is playing as yellow.
Developing this project, we found so many challenges, but that only means that we had lots and lots of extra fun, and we learned a lot. One of the main challenges that comes to mind is that Socket.io gets a little bit weird when handling state from within their events, either on server side or client side. There's not much documentation on this online, so we struggle a little bit trying to find solutions to this issue. I think that in the app everything is working so far, but we will keep on researching a little bit on that. Something else that we spent lots of time with was trying to create the Connect 4 logic. Once we had the Tic-Tac-Toe logic working, we need more time to actually develop that into a working product. But we learned so much trying to figure it out about 2D arrays, for loops, and handling reactor state through events. One of the things we're the most proud of is figuring out the winning logic for this project. As you can see, we started from a not very dry place. We literally hard-coded every single possible winning combination per color into this file. As you can see in the slides, some of my notes on there, we came back to it and we tried to refactor it. It was really, really fun to figure this one out. As you can see there, we created like a chain of for loops, and they're checking on diagonally, vertically, and horizontally for winning combinations. The snippet of the code that you're looking at right now is checking for vertical winning combinations.
Sadly, all good things comes to an end, and Carlos and I have had a ton of fun working on this project, and we have learned so much. And if we had more time, there's a couple of things we would love to add onto this project. And one of them would be the testing of Socket.io and the React router. And we would have refactored way more code, make it look better and more readable. We would like to implement the possibility to choose if you want to play Connect 4 or Tic-Tac-Toe. And last but not least, we'd like to make the project look a bit more sleek and modern.
Thank you very much to all the teachers who supported us, from building blocks to backend and front end. Thank you so, so much.
I just want to say thank you for the cohort and for this experience, and I hope I see you again soon.